might decommission right now at this point. Even Sanofi power plant, because of the leak into the boiler system, even though they fixed it, they still not, receiving a permit to, rerun or operate.
What's the chance of that coming up?
The chance of that coming up because of this shortage is very high. Because right now, we're so desperate for power, we have no choice. They're going to issue the permit. The Nuclear Regulatory Commission, they're looking into it. And I think within a couple of months, it's going to come back.
Or are they 20 years or so?
Maybe 5. My guess is 5. Not 20 years. Then we have a hydroelectric power plant. The hydroelectric power plant is like a Hoover dam. If you run to Las Vegas, what we do, we build a dam in front of a river, so we create a big, huge lake behind it. And then at the bottom of that dam, there are turbines. That water, because of the high pressure, it will turn the turbine, and the turbine generates the power. That we call the main source power plant. Now there is another one, it's called peak time power plant. This is a project that I was part of the design team for that. It's a very interesting project. It's in Cass State, which is an I-5 going towards Bakersfield. And this power plant only works during the peak time. What we did, we built a reservoir, and it's a 500,000 barrel of water up in the top of the mountain. And then what we did, we brought what we call penstock piping. It's a 4-pipe, that each pipe diameter is about 5 feet. Big of a pipe. So we brought 4 of them down, and then at the basin, which is our power plant, we have 4 turbines. We call turbines pumps. Then we have a huge lake that we built. Now, during the peak hours, between 10 a.m. to 4 or 5 p.m., we let the water go down this pipe, run the turbine at this power plant, which is right here, by the lake, and the water goes and collected in that lake. So we sell this power around, average of 20 cents per kilowatt hour during a peak time. And we are generating 580 megawatt of power. That's a lot of power. Okay? Now, what we do at 8 o'clock at night, this turbine becomes pumped. We pump that water back up to the storage, all mine. Now, the funny thing about it is, in order to pump this water all the way up to this reservoir, we use 700 megawatt of power to pump it back up. So as you can see, we are generating less than using it to send it out. However, we buy this power at night at 3.5 cents per kilowatt. So financially, we're making money. We buy 3.5 cents a kilowatt power. We pump this up, and then during the daytime, we sell it for 20 cents. That's the concept. We have a lot of these power plants for peak time. Peak time is during the summertime, when the temperature is 105 degrees, 115 degrees in the month of August, everybody using all their home air conditioning and going to cool off at the offices, factories, so we use a lot of power. If we don't have this kind of a peak power plant, you know what happens? We're going to have a rolling blackout. We have to shut down 2 hours in one area, 2 hours in another area in order to, survive. So we are desperate from the power point of view to have this. And financially, if it makes sense, why not?
Is it always, this is called, by the way, pumped storage. You can really affect power. Is it always the case that you need more power to pump the stuff? Or
Yeah,
is
because
this is part of it?
Yeah, because the elevation that we have here is about 2,200 feet. Piping that much of water through this big pipe, 2,200 feet up, to fill this tank up, we use a lot of power. Yes.
That reminds me, if we looked at a picture of something in Rio, of the water generation plants that pumps water up and then dumps it down, and then there's solar on the backside, would that work the same way?
Idea is the same, yes.
Yeah, it's the same thing.
So that it's probably not going to make power either.
No, this is more for the Olympic, they're talking about the Olympic in
Yes.
Rio,
Yeah.
okay. This is just something to showcase, it's not going to be very practical on the daily basis, but it's a showcase. They want to show,
So this is called, peak time power plant on a hydroelectric. We do have other peak time sources like harbor generating station, which is in San Pedro. That is a peak time power plant, and it's run in a combined cycle. There's a gas turbine and a steam turbine that we don't want to get into that technical part of how it operates, but it's called combined cycle, and that is also at peak time. Now, renewable sources, there are so many sources we call renewable because there is no fossil fuel involved, and we have plenty of them, and it's free. One of them, of course, is solar, wind, geothermal. Geothermal power plant is when you have water coming out of the ground at 212 degrees Fahrenheit. So what we do, we drill about 5,000 feet, we go down, we get pure steam, and then the steam will rush up in the pipe, we don't even have to pump it, and run a steam turbine. So that source is always there. We don't have to have a boiler, we don't have to use any fossil fuel to run it, and we can generate power. Today we have tidal wave, we generate power from ups and downs of tide in the ocean and even in the river. And biomass, that's another one. Fuel cell, hydrogen fuel cell, it's another source of renewable energy. So we are focusing on this concept. The last item you see says distributed generation. This is the problem. What we have is we have a power plant built in one corner, and we had all these transmission lines. Then we have distribution, and then it goes to your house and my house and school. And every time one of those power plants, something goes wrong, we lose huge amount of power. And then to make it up, we have to go and beg somebody outside of the state to help us out. However, the solution is so easy. If we do distributed generation, rather than making a large power plant, let's make a smaller power plant and connect it to distribution line. Then we don't have to be at the mercy of huge organizations. The biggest thing that we can do on a distributed generation is a solar.